All right, so we're going to get into 1.7. 1.7, so I want you to take out your notes. I don't have a organizer for you now, so you're just going to have to write notes in your notebook, wherever you want to write them. But you do need to take notes here. So 1.7, you can title this as Transformations of Functions, and here are your learning targets for today. I can apply translations to the graphs of functions. I can apply dilations to the graphs of functions. A translation is simply going to be a shift left and right, up and down of a graph. A dilation you can think of as switching the shape of the graph. So changing the slope, changing the way it looks. And then also the third learning target is I can apply multiple transformations to the graphs of functions and use transformations to write equations from graphs. So I want you to write those learning targets down, and then we're going to get started. And again, feel free to pause videos when you need to. All right, so the first thing I want you to put in your notes is just a title here, and I want you to write parent functions. There are 4 functions that we are going to quickly describe that you should be familiar with. And sometimes in Algebra 2 we call these function families. The first is called the constant function. So I'm just going to write here the title of it. This is going to be the constant function, and we're going to do a graph of it. So underneath that, I want you to just sketch out a quick x and y graph. A constant function would just be a horizontal line. So if this is our graph, a constant function, for example, could be horizontal line that goes through any of these points. So I'm just going to draw an arrow through here. And let's just say that this is at, this is at y equals 1. So below it, or sorry, to the right of it, we can say f of x, this constant function, an example would be f of x equals 1. It just equals a constant, right? That could be f of x equals 5, f of x equals any number. The domain of this function would be all real numbers, so negative infinity to infinity, and the range is just going to be that one y value, which is just 1, right? So we could say, I guess interval notation, we could say 1 to 1. Okay, set builder notation might be a little bit more friendly here, where we could say it's going to be all the f of x values such that f of x equals 1. That's another way to write the range. So that's our first function. It's just the constant function, right? And it's just a horizontal line. Let's do another one. We also want to know about what we call the identity function. Okay, so the identity. Okay, this function, if we graph it, is just going to be y equals x. So I'm going to put it. Here's a little graph. The f of x here off to the right that we're going to write, f of x equals just x. It's the identity function, so it just means whatever we plug into it, it's going to be the exact same output. So if I plug in x, or if I plug in 1, I get 1. If I plug in 2, I get 2. Really, it's just a line with a slope of 1. So if I were to graph this, it would just be a kind of like a 45-degree angle with slope of 1 going like this. So there's my line or sketch of this identity function. So let's talk about domain and range here. Domain for the identity function would be all real numbers, and the range would be all real numbers. Okay, we could also say this is a one-to-one function and it's onto, right? And so that is the identity function. Let's go to the next one. Talked about the next one yesterday, but this is the absolute value. So I'll just label this as absolute value function. If we sketch that, we should already kind of know what this looks like, right? We have basically like a V. We have a vertex, and the most basic, again, we're just doing the parent graphs. So this is the most basic absolute value function we can possibly have with none of the parameters attached to it. So this would be labeled as f of x equals the absolute value of x. So what does that look like? So that means we have basically a vertex at 0, 0. And we have two branches of this thing, one going up and to the right and one going up and to the left. We should have seen this graph before. So that's what the absolute value function looks like. Let's talk about domain and range for absolute value. So domain here would be all real numbers. The range would not be all real numbers. The range would be anywhere from 0 to infinity. Okay? Or in set builder notation, that would be all f of x's such that f of x is greater than or equal to 0. Right? Again, we only have to put one of those notations, but it's good to know and review interval versus set builder. I know the book uses all set builder. So that's the absolute value function, and that's the parent function, so the most basic one we can get. And lastly, let's make space for the quadratic function. So let's label this quadratic. And quadratic function we'll sketch out. And that's just going to be f of x equals x squared. Anything quadratic is just going to have 2 as an exponent, so it has a quadratic term there. So we're just going to say x squared. The graph of this is going to start, and just think about the input-output, right? So if I plug in 0 in for x, my output is 0, so I have a point here. If I were to plug in 1, I would get 1. So if we start to sketch this out, you have like 1 goes to 1, but if I plug in like 2, 2 squared is 4, so that would be 1, 2, 3, 4. That would go up here, and 3 squared is 9, so that's way up here. So this graph is going to start to look like a parabola. In general, it's just going to look like an opening up parabola, like that, which I think you've probably seen before, right? The domain for this is going to be all real numbers, and the range, similar to absolute value, is going to be anywhere from 0 to infinity. So we're going to include 0, and we're going to have infinity. So these are the parent functions that you should generally know, right? We have a constant function, identity function, absolute value, and quadratic. And you should know the general characteristic, the general shape, and the domain and range of those things.